Salam sejahtera. These are the group project presentation for group 4. First, I'm gonna introduce that our group member. My name is Fabian Ling Leseng. Next is Muhammad Faiz Azwan bin Muhammad Zain. Third is Nur Syamimi bin Ahmad Zikri. And last is Zafira Razati binti Zamri. As for my part, I'm gonna explain for the executive summary. For creating a model of determinate trust and analyze, we should evaluate based on the model that we designed. We have to use our own idea in creating a bridge that can support equally past the requirement that we needed. Third list, determine the internal force in every member of the trust using alternative method. Trust bridge is the one of the oldest type of modern bridge. A trust bridge must economical to construct because it uses material efficiently. The most important for this project is we should have teamwork, and knowledge is very important during creating the model. We use the Lean Pro software to analyze the bridge, whether it is when we get the result, we have to compare it. Lastly, for the executive summary is we have to determine the deflection using the replacement of statically determinate plane trusses method.
Introduction. A truss bridge is economical to construct because it uses material efficiently. Load applied to the truss is transmitted to the joint in case of each individual member to be in either pure tension or compression. Truss bridge is a bridge that load-bearing superstructure is composed of a truss, a structure of connected elements, usually forming triangular unit. The connect element may be stressed from tension, compression, or sometimes both in response to dynamic loads. Next is bridge design. As you can see, 3 images from this slide. First, this is front view for the truss bridge. Next, this is third dimension view for truss bridge, and the third one is dimension of the bridge. In this design, I got inspired to make this design from Southern Pacific Railway in California. Even though this design is simple, this structure can stand a train. Because of that, I made the decision to design our truss bridge based on Southern Pacific Railway.
So for results and analysis for LeanPro, to analyze the truss bridge, the nodes or joint, members, and support is first placed correctly according to the design, including the dimension. A load of 50 Newton is then applied to each point, which is point A and point B. And then we run the analysis. Based on the analysis, it can be seen that the reaction forces is the same for both support, which is 50 Newton. Next, for internal forces, the result shows the value of the internal forces on the members. Red indicates tension while blue indicates compression. For deflection, it can be seen that the value obtained is negative 0.0000003, which is almost zero.
Okay, now I want to explain the calculation for this project. So this is our bridge. First of all, we need to find the determinacy. The formula is M plus R equal to 2G. M stands for members, R stands for reactions, and J stands for joint. So our bridge have 21 members, 3 reactions, and 12 joint. So we need to substitute all the value, and we got the answer is 24 equal 24. Therefore, our bridge is statically determinate. Next, we find the reaction forces, which is VD and VC. So we got the same value for both, which is 50 Newton. Okay, next, by using alternative method, we find the external forces. As you can see, the compression members are CH, HI, IJ, JK, KL, and DL. For tension members are CE, AE, AH, AF, BF, BL, BG, and DG. And the last one are zero force members, which is EH, AI, AJ, FJ, BJ, BK, and GL. We proceed to the next step to find the internal forces. We put 1 Newton point load at the middle of the bridge and just ignore all the load that we have before and repeat the same method like we used before. First, we need to find the reaction. Then find the internal forces by using alternative method. For compression members, we have CH, HI, IJ, AJ, BJ, JK, KL, and DL. For tension members, we have CE, AE, AH, AF, FJ, BF, BG, DG, and BL. And for zero force members, we have EH, AI, BK, and GL. Okay, we move to the next step. Find the deflection by using displacement of statically determinate plane trusses method. We need to substitute all the value that we found before into the table. The formula of deflection is deflection at point F is equal to sum of F times mu times L over 8 times E. F stands for external forces, mu stands for internal forces, L stands for length, A stands for cross-section area of the members, and E stands for modulus of elasticity. The value of A is equal to 15 millimeters square and the value of E is equal to 105 times 10 the power of 7 Newton per millimeter square. So we have all the values and we need to substitute all the values into the formula. So we got the deflection at point F is equal to 8.63095 times 10 the power of -6 millimeter.
For discussion, the results from LinPro and manual calculation are compared. For reaction forces, we know that the vertical forces acting on each support is the same, which is 50 Newton. It shows that the total of reaction forces is equal to the external load applied. Therefore, it shows that the forces acting on the bridge is balanced. Next, for internal forces, the value obtained for both results is different. However, the compression and tension members are the same members for both results except for zero force members. We conclude that the difference is because LinPro calculates based on the load applied on the points, which is point A and point B, while manual calculation is made based on one unit load at the middle point, which is point F. Lastly, for deflection, the value obtained from both results is almost zero because there is a slightly difference in the value, which means that the values indicates very little deflect. Therefore, we conclude that the design of the bridge is strong and stable for the loads applied.
As for the summary of our project, the most important step in design process is to understand the problem. Next is analyzing of the bridge must be detailed to avoid failure. Teamwork is very important, as also knowledge is important in completing this project. Lastly, for the summary is design of the bridge must be suitable, safe, economic, and have on aesthetic value. That's all.